This is Miranda, and that cliff right there is the tallest known cliff in the entire solar system, roughly 20 kilometers straight down. If you jumped off it, you'd fall for about 12 minutes before hitting the bottom. That's not the strange part. The strange part is that nobody can fully explain why Miranda looks the way it does. This moon appears to have been violently shattered, and then somehow reassembled. Terrain that should not exist next to each other does. Geological features that take hundreds of millions of years to form sit directly beside features that look brand new. It's as if someone took 4 completely different worlds, smashed them into pieces, and glued them back together at random. Planetary geologists have been arguing about Miranda since Voyager 2 flew past it in 1986, and the more we study it, the stranger it gets. Miranda is one of Uranus's 28 known moons, small, icy, and orbiting close to the planet. It measures only about 470 kilometers across. By the standards of the solar system, it's tiny, barely large enough for gravity to have pulled it into a roughly spherical shape. A world this small should be geologically dead, cold, dark, and featureless, like most small icy moons in the outer solar system. Frozen solid billions of years ago, preserved in silence ever since. Miranda is none of those things. When Voyager 2 captured its first close images of Miranda's surface, scientists were genuinely stunned. What they saw looked nothing like any moon they had encountered before. The surface is divided into dramatically different regions that sit next to each other with almost no transition. Ancient, heavily cratered terrain, the kind that accumulates over billions of years of meteorite impacts, butts directly against young, smooth regions with almost no craters at all. Enormous parallel grooves and ridges cut across the surface in patterns that suggest massive internal stress. And right at the South Pole, the most dramatic feature of all, Uranus, the cliff that drops nearly 20 kilometers in a near vertical plunge to the floor below. Put that in context, the tallest cliff on Earth, the east face of Thor Peak in Baffin Island, stands at about 1,250 meters. Uranus is roughly 16 times taller. On Earth, a cliff that size simply could not exist. Our planet's gravity and internal geological activity would collapse it long before it reached that height. Miranda's much weaker gravity allows such extreme features to persist. But the fact that it exists at all still demands an explanation. How does a moon 470 kilometers across produce a cliff nearly 20 kilometers high? The most dramatic explanation, and the one that captured the public imagination for years, is that Miranda was shattered. The idea goes like this: early in the solar system's history, a massive impact struck Miranda with enough force to break it apart completely. The fragments drifted in orbit around Uranus, slowly pulled back together by their own gravity, and reassembled into the chaotic patchwork we see today. Different pieces, from different depths of the original moon's interior, ended up jumbled together at the surface. Deep crustal material sits next to surface ice. Old terrain sits next to young terrain. Nothing matches because the pieces were never in the right order to begin with. It's a compelling image. A moon that died and came back wrong. But here's the problem. Most planetary scientists today don't think that's what happened. The reassembly hypothesis has largely fallen out of favor, and not because it isn't dramatic enough. The physics don't quite work. Models of how fragmented icy bodies reassemble suggest the result should be a fairly uniform, homogeneous surface. The different pieces would mix thoroughly as they came back together, not preserve distinct terrain types sitting neatly side by side. What Voyager 2 saw in Miranda is too organized, too structured to be the result of a random reassembly. So if Miranda wasn't shattered and rebuilt, what created those bizarre terrain boundaries? The leading explanation today involves something called corona, and Miranda has 3 of them. Coronae are large, roughly oval or trapezoidal geological features, typically 200 to 300 kilometers across, covered in parallel ridges and grooves arranged in complex, almost geometric patterns. They're unlike anything else seen on icy moons in the solar system. The 3 coronae on Miranda, named Arden, Elsinore, and Inverness, are the dominant features of its surface and the core of the geological mystery. One major theory is that the coronae formed through a process of partial melting driven by tidal heating. Even though Miranda orbits Uranus at a significant distance today, scientists believe it may have passed through a period of orbital resonance with other Uranian moons, a gravitational tug-of-war that repeatedly flexed and squeezed Miranda's interior, generating internal heat. That heat would have partially melted sections of the moon's icy interior, causing denser material to sink and lighter material to rise and erupt onto the surface. The coronae would then represent regions where this upwelling material spread out and froze, creating the distinctive rigid terrain we see today. Under this model, Uranus, that extraordinary cliff, would be a consequence of this same tectonic stress. as sections of Miranda's crust were pushed up and pulled apart by internal forces, massive fault scarps formed. The cliff is essentially the exposed face of a geological fault on a scale that has no equivalent anywhere else in the solar system. But even this explanation has problems. The orbital resonance that would have driven the tidal heating would have had to be quite specific, and the window of time during which Miranda occupied that resonant orbit is unclear. Models disagree on whether the heating would have been strong enough to produce features of this scale on a moon this small. And the sheer diversity of terrain types, the sharp boundaries between ancient cratered plains and young grooved corona, remains difficult to explain cleanly under any single model. What Miranda is telling us, if we're honest about it, is that small icy worlds are far more geologically complex than we assumed. For decades, the working assumption in planetary science was that geological activity, volcanism, tectonics, surface renewal, required large bodies with significant internal heat. Jupiter's moon Io is geologically active because of intense tidal forces from Jupiter itself. Enceladus surprises us with its geysers, but is locked in orbital resonance with other Saturnian moons that continuously powers it. But Miranda is tiny. Its internal heat budget should be nearly zero, and yet its surface screams geological violence. It tells us we are missing something fundamental about how small icy worlds work, about what forces can reshape a moon, about how long geological processes can persist in the outer solar system, where everything is supposed to be frozen and dead. We have seen Miranda exactly once. Voyager 2 flew past in January of 1986, the same flyby that gave us our only close look at Uranus itself. The encounter lasted hours. The images it captured, while extraordinary for their time, covered only a fraction of Miranda's surface. Voyager 2's trajectory took it past Uranus' south pole, which meant only the southern hemisphere of Miranda was illuminated during the flyby. The northern hemisphere is almost entirely unknown. We have no idea what geological features might be hiding there. The Uranus orbiter mission that scientists are now advocating for, the one prioritized in NASA's Planetary Science Decadal Survey, would change all of that. A spacecraft in orbit around Uranus would be able to make repeated flybys of Miranda over years, mapping its entire surface, measuring its internal structure with gravitational instruments, and finally giving us the data needed to settle the debate about how this moon came to look the way it does. Until then, Miranda remains one of the most visually striking and scientifically unresolved objects in the solar system, a world the size of a small city that somehow generated a cliff 20 kilometers tall, a surface that looks like it was assembled from spare parts, a geological story written in ice and stone that we have only barely begun to read. One flyby, a few hours, and a moon that has been asking questions ever since.